It's really been a while since the last video. I believe that was probably, when was that? That must have been around October or so, and I think we were in a very rainy Seattle. I remember that. That was not the best lighting conditions out there, and it was very wet, and people were looking at what was going on. But yeah, like I said, it's been a while. We have been very, very busy, so don't confuse the lack of update videos for a lack of progress. A few things happened. First of all, I moved. I'm still in beautiful Houston, Texas. I just moved down the street. But you see, I have a brand new garage, and I think you hopefully will see this fill up more and more over time. I'm waiting for a few deliveries. It's honestly, deliveries are a little messy right now. It's really all over the place, but we'll figure it out. Today, we will be talking about Alpha 10. And Alpha 10, I wrote this down, so I got my trusty notes with you. I wrote down Alpha 10 and I thought, man, Alpha 10? That's 10 alpha releases. I think it's the highest I ever went with alpha releases in my entire career. But you know what? We wanted to get this out to people as soon as possible, and this is really a giant project. So yeah, there's going to be a bunch of alpha releases. There's more coming. We're going to be talking about Alpha 11 in just a second. But also, I think to be fair, if you count this right, we're really at Alpha 6 or so, because we've had 3 or 4 releases that were bumped immediately before release because there was an issue that was discovered in the last moment. But still, Alpha 11 in just a second. And I think the last release update, or the last release, must have been right before DC, right before ShmooCon, which was fantastic, by the way. Hope to see you all there next year. Anyways, that must have been in early January. So it has been more than 3.5 months since the last release, and that is because there was a giant feature in this one. That is Wi-Fi trilateration. I started to use the word trilateration. I used to call it triangulation all the time, and I would like to apologize to everyone who actually understands physics or math, which is certainly not me. I have to read all of this up kind of on demand. But trilateration, no, triangulation is basically determining the position of something if you have 3... I'm going to screw this up so bad. You basically have three sensors, is what I'm going to call it. Could be anything else that is recording an angle from where the signal or the source is coming from. And we don't have that because nzyme is not prepared to do anything when it comes to angles or with a directional location finding. So what we do instead is trilateration. And trilateration basically means we use the signal strength of at least 3 locations that recorded the signal, and we then use that to translate that based on a formula into the distance from that. And so now we have 3 circles of the distances, and then all sorts of math can happen, and now we can tell roughly where that signal most likely came from. That's trilateration. So whenever I said triangulation in the past, that's not actually what we do for now, because also in this garage I have this electronics lab now, and I have some insane ideas about how maybe we could do something with a more directional location finding, but that's all future talk. We're not going to talk about this now. Anyways, that is the big feature, trilateration. So basically, we can now tell where a signal source is from. The algorithm behind that right now is pretty simple. The idea was that we're going to build the entire UI around it, the workflow around it. We're going to allow you to create a location for a tenant that's part of an organization. And then that location has multiple floors. Those floors now have the taps on the floors. You can drag and drop those onto the floor plan and tell nzyme where those taps are. And once you did that, and once there are more than 3 taps on a floor, and once nzyme determines that the signal source was likely on that floor, you can use the web interface and you're going to get a heat map of where those signals came from. And the idea was that we can easily improve that algorithm and make it better and better and better over time, and start with something simple that has less configuration and that's more reliable, and allow people to do everything around it and then we'll improve that algorithm over time. So right now you will notice that the algorithm is, for me, and I've played around it quite a lot, I think I'm getting an accuracy of maybe 2 to 3 meters in this house. There's all sorts of factors in play. Also, what is that in feet? 2 3 meters, that's like 6 to 10 or so feet. I don't know. Need somebody else go look that up. I think that's about it. And I think it's actually a little less. Doesn't matter. The matter is that you get a pretty accurate-ish representation right now where that signal most likely came from. The problem with that is physics. The problem with that is also the complexity of the algorithm. Like I said, we'll add more to that in the future. But right now, it simply assumes a direct path with a very static path loss on the way. So let's say your tap is 10 meters away, then we will assume that on these 10 meters, the original signal will lose a certain amount of dBi on the way. And then based on that, we can estimate where that signal is. We do not yet let you tell us there is a drywall in the way, or there's a window in the way, or there's a large open area not in the way, I guess. That's all coming in the future. But for now, please try this out. If you want to prepare for that and you're maybe not ready for the upgrade yet, just install at least 3 taps on a floor. We've seen that the best results come if you have at least 4 taps on the floor and you put them on the actual outer corners of those of the floor. That gives you the most accurate results and the best coverage of the floor. And then upgrade and try to use it. And please, please, please tell us where you get confused. There is a lot of areas where someone can get confused. So please try it out. And please let us know where something is unclear, where it's confusing, where it's annoying, or where it straight up doesn't work. This is what we're looking for. So please let us know on the various channels that are out there. All right, I'm back in my notes. So alpha.10 is probably, I'm going to lean a little bit out of the window now. Alpha.10 is probably the second to last release of the Wi-Fi complete milestone. Wi-Fi complete means for us, this is everything that we had envisioned for version 2.0 of nzyme. Once that is there, we will start to focus on the Ethernet part of nzyme and maybe even one more subsystem, but that's to be determined. That, of course, doesn't mean that we cannot add more to it. That doesn't mean that we can make changes. But that's where we kind of switch our focus. Alpha.11 is currently planned, which is the next one, is currently planned to close out that milestone. That one will have a coverage overview. So that means that you'll be able to see which parts of the 802.11 protocol or Wi-Fi you're actually covering to make it easier for you to cover everything so you don't miss anything. That will also include the overview page of Wi-Fi right now, which right now is just a giant box that says that it's not there. And then there is also a new functionality for channel width modulation. And I will try to explain this. And the real Wi-Fi experts out there, as in the people who fully kind of not understand, but the people who maybe really live the Wi-Fi standard in its entirety, which I don't. I'm thinking about it from a security perspective and I always get hung up on like small details very easily. They may not be happy with how I describe this, but the channel width is basically, especially in the newer versions of the Wi-Fi standards and protocols, a client can negotiate with an access point. I'm going to get in so much trouble. A client can negotiate with an access point to use basically a wider bandwidth. So the signal is not only on one channel, but it will be over multiple channels, so to say, which allows it to transmit more data all at once. The problem, there's a multitude of problems with that. It does make it faster, but it also introduces other issues. But a lot of devices will do that, especially if you need a lot of throughput. The problem is that if your Wi-Fi sensor, in this case nzyme, is not tuned to that width, then it will simply not see what's going on it. So you're blind, basically, on that. And a lot of those channel widths are actually quite popular now, so we want to make sure that you don't miss any data. And so there will be an automatic channel width modulation, which means it will find out which channel widths your adapters do support and then cycle through that as you as you don't do anything. As the system is cycling through channels, it will also be cycling through these channel widths. And then we're currently planning to also let you define that if you want to, but usually it's a good idea to just support all of them because you want to see everything, right? The other thing, and this is now kind of bleeding into the Ethernet topic a little bit, is also new in this new release. So you will already be running this. There's a new data backend. So the way that the tabs are collecting and transmitting their data to the nzyme servers or nodes has been changed massively. That is all in preparation for the Ethernet work coming. That will simply have so much more data going through the tabs than with Wi-Fi traffic. It's just by nature so much more stuff. That should not make any difference to you. That should just work. But please, if you notice any sort of weird behavior of your tabs, please let us know. We would love to debug that. But our longer term tests so far have worked really well. And then the tabs are already parsing TCP data. I was in New York City for the glorious NAT Gala, and I had a hard time working on trilateration because I'm on the go, right? I don't have 4 tabs on every floor of the hotel I was staying in. So I started to work on the Ethernet part a little more. So nzyme is now already collecting TCP segments and is also reassembling these segments into sessions and then analyzing those sessions. So it can already tell you if there's an unencrypted HTTP in it. It is almost ready to tell you if there is TLS in it, what kind of TLS, what the certificate looks like, report all of that back up to the node and give you all the cool analytics and alerting on that. It just doesn't do that yet. It does all the work. If you hook that up to an Ethernet connection, it will do all of that. So please do that if you want to test it. It just doesn't expose any of that yet in the web interface. That is coming in the coming releases. And I am really looking forward to that. And I think, and I'm just glancing at my notes once more over here, I think that's it. Like I said, this is one giant feature. This was the last really, really big feature that had a lot of uncertainty, especially when it comes to planning in the Wi-Fi milestone. So get ready for Wi-Fi to be kind of in beta, honestly, which means feature complete, not perfect, certainly some bugs, a lot of details to still iron out, but then you'll see that a lot of the work's going to switch over to Ethernet. But please keep the feedback coming. Please keep on using it. Please keep on trying it out. As always, these releases are supposed to just be rolling into production. So if you use this now, there will not be a point where we say now you have to throw everything away and start over on the way to production. These will upgrade their way into the final version. So there's no harm or no wasted time if you get started with nzyme right now. And I think that's it. I'm hungry. I gotta eat. This all took much longer than I thought to set up for the first time in the new house. Cats are hungry. Dog is hungry. So I'm gonna feed them. I'm gonna feed myself. It was fantastic doing these again. Again, please try it out. Let us know how it works. And I will see you very soon, hopefully. Thank you very much.